Welcome to Session 4, Triangle Area. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to identify a base and its perpendicular height, even when the triangle is tilted. Explain why triangle area is half the area of a related parallelogram or rectangle. Rearrange the area formula to find a missing base or height. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The A diagonal can divide a rectangle into equal area triangles. The perpendicular height idea transfers to other shapes. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A triangular banner with base 14 in and perpendicular height 9 in uses, 1 divided by 2, 14, 9 equals 63 in squared of material. A slanted side marked 10 in does not replace the height unless it is perpendicular to the chosen base. A triangle can be paired with a congruent copy to form a parallelogram. That construction explains the factor of 1/2 and also explains why only a perpendicular height works. Estimate with a nearby rectangle or familiar benchmark. The estimate does not replace the exact calculation. It tells you whether the exact result belongs in the right neighborhood. Now add a precision check. For every area or boundary problem, identify exactly which segments form the base, height, radius, diameter, or outside edge. Convert units before combining measurements, keep full precision during the calculation, and round only once at the end if the context requests a decimal result. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, choose any side as the base, then locate the height measured at a right angle to that base. Second, compute b times h, divide by 2, and label the answer with square units. Third, for an obtuse triangle, extend the base if needed. The perpendicular height may land outside the triangle. Finally, if area is known, use h equals 2a divided by b or b equals 2a divided by h. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A triangle has base 16 and perpendicular height 9. What is its area? Step 1 is to organize the information. Choose any side as the base, then locate the height measured at a right angle to that base. Step 2 chooses and sets up the relationship. Compute b times h, divide by 2, and label the answer with square units. Step 3 carries out the mathematics. Triangle area is 1/2 base times height. 1 divided by 2, 16, 9 equals 72. A useful check is to the height must be perpendicular to the base. The answer is 72. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it's your turn. A triangle has base 15 and perpendicular height 12. What is its area? Write a formula or a relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 90. Triangle area is 1/2 base times height. 1 divided by 2, 15, 12, equals 90. A useful check is to the height must be perpendicular to the base. Use this coaching check as well. Draw a small right angle box where the height meets the base. If you cannot place that box, reconsider the height. Session recap. First, choose any side as the base, then locate the height measured at a right angle to that base. Next, compute b times h, divide by 2, and label the answer with square units. Then, for an obtuse triangle, extend the base if needed. The perpendicular height may land outside the triangle. Finally, if area is known, use h equals 2a divided by b or b equals 2a divided by h. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.